Newton's first law of motion simply is an object at rest will remain at rest unless acted upon on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is often called the law of inertia.
What does it mean? A lot of words. Okay. Pencil. At rest. And now, it says an object at rest will remain at rest. It will stay where it is unless it's acted on by a greater motion, which will move it. And inertia means something that's inertia. It's just at rest. So when you're sleeping, inertia, and you're sleeping really good, and the alarm goes off, you get up. That's a greater force. Just to turn off the alarm.
Has anyone ever did the funny part of parking a car but not putting it in park? Right, so what happens to it then?
Now
It
this
keeps going.
well, if you have, especially if you have a stick or standard, if you have it in an automatic, when you put it in, like you have it in neutral, and it's on a nice straight spot, but you have it in your driveway, it usually has a little tilt to it. It rolls down.
You didn't put it in park, it's still in drive, therefore it's still going to want to behave like it's in drive. It's simply just called the law of inertia. Now the second law of motion. Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object.
Okay. A baseball. You take a baseball, acceleration is when a force acts on it, and you're going to throw it. That's the force. The greater the mass, okay. Suppose instead of throwing a baseball, you're going to throw a bowling ball. The greater the mass, the more force has to be done. That's what you're talking about.
So everyone unconsciously knows, subconsciously, nice one, knows the second law. Everyone knows that the heavier objects require more force to move the same distance as lighter objects. That's why whenever you're helping someone move out, you want to do something before the couch and bed gets moved. Easier work for you, right? And that leads us to our last and my personal favorite. For every action, there is an equal and opposite reaction. Meaning that for every force, there is a reactionary force that is equal in size, but opposite in direction. That is to say that whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. Now, we've all been in a situation like this before.
Seesaw. You get to the bottom, and you decide that you're going to kick off really hard. What happens to you? You're down, you kick off real hard, you go up. Do you stay on the seesaw, or do you leave the wood? Depends on how hard you kick off, you can actually kiss the wood, go forward. And that's, and that is part of the money-making lesson you're going to see today. Now, some of you have seen this already, so don't steal my thunder, please. And 6 nails. These are called common nails, and that's because of their heads. There's 2 types of nails, common nails and finishing nails. Finishing nails don't have a head. These are called 22 penny nails. And the reason why they are called 22 penny nails, because 100 years ago, this size, you can only get 22 of them for a penny. They each take a pound. That's why they come in number 16 penny nails, 16p. That was 16 nails for a pound at that size. And they come in various sizes. And the size of the nail makes a difference. And the concept is to balance all 6 of these on this. And like I said, it's a money business. You go to a party, make sure you practice. Anybody recognize the word? 2 by 4. Why'd you call it 2x4?
4 inches wide and 2 inches long.
At one time. But if you measure this now, it's no longer 4 inches wide
Cut some
and
down.
4 inches by 2 inches. It's smaller. Because it's
Why
less
they
and
make
less.
everything smaller?
Because less and less wood, you can get more out of a tree at this size. And also, another thing, when you build a house, now you're supposed to put these in the wall 16 inches apart. In old houses, they're 12 inches apart. 16 inches, you use less lumber. Okay, a little construction. So here we want to do. Anyone want to try it?
So what are we supposed to do?
Balance all 6 of these nails right on this one. That's the concept. Balancing 6 nails on the head of that one nail. Because we are doing this law right here. For every action, there's an opposite and equal reaction. Like I said, it's the size of the nail and the construction. And I've had people say, come up, oh, I can just go and put a nail right here. Sometimes it stays, sometimes it doesn't.
That time it did.
That did. But that, if you get the balance right here, that's only one nail, what about the other 5?
I'm trying to figure out how you're gonna put the other
Oh,
five
okay,
on
this
top.
is how it's done. You take one nail, you make it parallel to the wood. Now, if you can't see the back, stand up. You take another nail, you make perpendicular to the first one. You take another nail, and you make it opposite perpendicular, and the next one right next to it. The last one, parallel the first one. Notice 2 on each side. And reaction, an opposite equal reaction. It's there. Over the top. If my nerves hold out, nerves that hold out, I might have to ask Mr. Dan to come replace me on this one.
There's signs going on, y'all just gonna crane your heads. Get up, walk around. Look
Yeah.
at all the open space we got, guys. Come on.
Otherwise, I don't want to get up in there.
Nerves are sealed. Okay, now, for action, there's an opposite equal reaction. So when I touch this side, the other side goes up a little bit.
A seesaw.
A seesaw, right.
Seesaw.
And this is Newton's law of motion. For every action, there's an opposite equal reaction. Notice how it's constructed. You have the heads of the nails. Everything works opposite. One this way, one that way. 2 on this side, 2 on that side. And like I said, go to a party, practice first. There's always going to be someone at the party that's going to be a loudmouth and bet you. Never bet more than you can afford to lose. And the most I've ever come home with was $50.
So,
Wait, one more thing. Now, the reason why I chose a 22 penny nail is that when I first got it, I was learning about the lesson, I used what's called a 12 penny nail. And when I put it into the wood and set it up, the tips of every nail touched the wood. Someone can say, oh, the tips are holding it up. And that 16 penny nail, it barely cleared the wood. So I jumped to a 22 penny nail, nice and high off the wood. But if you're going to do it, make sure your nail that's sticking in the wood is solid. What is that position when it's straight up from the wood? What geometry word is that? If you're standing up, no, am I
Starts with a
parallel
P.
or am I perpendicular?
Perpendicular.
perpendicular. So you have to make sure that that nail is perpendicular, because if you have it on an angle, guess what's happening? Your flat spot's going to be, right, it won't balance. So you have to make sure it's perpendicular. Perpendicular. And again, it's Newton's law, and it's a moneymaker.
So, the question I got for you guys is, this third law of motion, it's not just used in the real world, meaning the physical world. For every action, there is an equal and opposite reaction. Do we come across this in reading, social studies, science, literature? What do we call the phrase when we talk about it in reading? Cause and effect. So what does cause and effect mean? It means that for every action there is an opposite yet equal reaction. So, your alarm clock goes off in the morning. What do? You hit the snooze button. The cause is what? That noise. The effect is you slamming your phone as hard as you can to get it to stop. What are some other examples of cause and effect?
Being interrupted when you're doing something or watching the game or something.
Right. Well, you're watching the game and someone comes and bothers you. What's your reaction? What's the effect? You're mad. You're angry. So think about when you woke up today. In all likelihood, you were probably woken up by the sound of the alarm clock.
Or someone else.
Or someone else making too much noise.
I'm telling you to get up.
Now, the loud sound of the alarm clock was the cause. Without the alarm, you probably would have overslept. In this scenario, the alarm had the effect of you waking up at a certain time. This is what we mean by cause and effect. Oh, no. Oh, no. So, what I want you guys to do is, if you have a paper, start thinking about some examples of cause and effect. What I mean by that is, you think of your own, experiences, your own life, or think about history. Think about things that happen in science. And think of 3 examples of cause and effect.
Because you went through plenty of cause and effect before you even got there. It's experiment. Like that cause and effect.
The cause was when Mr. Tom performed the experiment up here. What was everybody in the back rows doing? Craning their necks trying to look, because everybody just refused to stand up to get a shot of the good stuff. So, what's an example of cause and effect? As we brainstorm. What you got, Tyler?
Like, on the way to school, like, the light turns red, everybody stops.
Light turns red, everyone stops. We go. So what magical properties does that red light have? Yeah, it's just an understood symbol. What happens when a car doesn't stop at a red light? What's the effect? Crash. So, there's our cause, there's our effect. For every action, someone's speeding through a red light, there's an opposite yet equal reaction. Someone's going to T-bone that car. So what are some other examples? You should be good with that, huh? Is it turned on? Is it dead?
Like when you getting out of your car and your headlights is on, the little ding 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 bell
Right.
goes on.
That's a perfect example.
You gotta let you know if your headlights on, unless you just don't hear it and come back and your lights still be on.
Right.
When you're trying to start the car and it says,